Right, so at this time we have the example up here on the board talking about students at Central High School complaining that the soda machine is frequently empty. They are going to student council to study the problem. Here's the graph on the right side. You have the graph on your paper, but not the example. So go ahead and read the example and answer the 4 questions, and I'll come back to you in a moment. Question A, based on the graph, at what times is the soda consumed most rapidly? What would you say to that one? Go ahead. 11:30 to 12:30. So let's see, right in this region here, so right here, this very steep downward slide, okay? And any other times? Go ahead. 3 to 3:30. What do you think is significant about those times during the day, during the school day? What do you think the first one is? Lunch, and then when school ends. So that's when the machine is consumed most rapidly, the pop. Okay, so the purpose here is to just be able to interpret graphs, all right? This is sort of a silly little example for it, but just to understand as time moves what's happening to the y-axis. When is it refilled? One time. Around 10 a.m., boom, right there, good, it's refilled. When else? Around 4:30, refilled. What's going on in this one? It's like halfway, 3/4 refilled, not the whole way. Maybe they got tired, maybe they ran out of supplies and had to go run out to Costco or something like that. Not that I support Costco in any way, but let's go down to C. When is the machine empty? Completely empty. Go. When is it empty? I can't advertise for companies on the video, okay? Go ahead.
12:30.
Good. 12:20 and 3:30 to 4. That's when it's empty. Excellent. Good. And what do you think they should do to solve the problem? Get another machine or refill it more often. Agree? Anything else that could be done? Yeah?
Fill the machine during the highest consumption times.
Fill the machine, especially during those highest consumption times. Good? Increase the price. Interesting. If you increase the price, what might happen? They wouldn't buy as much, right? Supply and demand. Economics 101. What is on this next slide? Take a look at this graph. Important things here for interpreting graphs. How is this graph? It's the same concept. This is the morning time. Same pop machine. Number of cans of soda in the machine, or pop. And what's different about how the graph looks this time compared to before? Before it was like this, right? Something like that. What's different? Rosemary? Okay, there aren't slants. You ever play like Chutes and Ladders, right? There aren't slides, up and down slides like this. Instead, they have these guys which look more like what? Steps. This is called a step function. Why do you think, what's up with these rapid, abrupt changes in steps for the pop machine? Why would they be boop, boop, boop? Sorry, I can't see that on the video. I was going boop, boop, boop. Why are they stepping down instead of sliding down like on a chute? What do you think, sir? Good. You can only buy full cans or bottles of pop. So if the line was going like this, that would indicate that the machine had 30 cans of soda. Then it had 29.999 cans of soda. Then it had 29.9 cans of soda, right? Then at some point it had 24.5 cans of soda. What, did someone buy half a can? It doesn't work that way. This is what's called a discrete graph. You want to clarify that on your paper. A discrete graph is one that changes in whole number increments or integer changes. All right, it changes with whole numbers. No decimals, no fractions. If I was making a graph which was counting the number of smiley faces on this screen, would that be discrete or would that be more of a continuous style graph? Counting the number of smiley faces. That would be discrete because there's one smiley face, two smiley faces, three smiley faces, four. Now, if you were making a graph which was determining the radius of this smiley face as I did this, would that be continuous or discrete? Continuous. At some point, that smiley face had a radius of 1 inch. Then it had a radius of 1.3 inches. Then it had a radius of 5.5 inches, right? It covered all the fractions and decimals along the way. That's called continuous. And the graph that they had above was continuous. Wow, that's a large smiley face, Philippe. Okay? The last thing that we want to talk about on this slide would be what's up with the open and closed dots. Does anybody know what it means? Let's zoom in right here. At this time of day, 8 o'clock, let's pretend this is 22 cans of soda. Okay, and this is 27 cans of soda. Which is it? What does the machine have? 22 or 27? And how do you know? Open versus closed. What do you think? So at 8 a.m., does it have 22 or 27? How do you know it's 22? The filled dot indicates what? Closed. The closed circle means the point lives where? Here or here? Where does it actually live? If it's a closed circle, it lives on the closed one. Closed means the point is here. Can it be both? Can you do this? Closed dot here, closed dot there. Think about the pop machine. At 8 o'clock, this machine has 22 and 27 cans of soda. Can it be both? It's got to be one or the other. The open circle indicates that you get really close to there, but then it hops down to the next one. All right? The closed circle is where it lives. The open circle is not. It's like a placeholder. Got it? Good? Move on.